All right, folks, Fast Action is back in action here. On this page of notes, we're going to do a quick review of our transformations. Again, these are things that you should be familiar with, but it's always good to have a review to go back and look at, and there are a few of them that are a little bit tricky for us. On this first one, I'm going to write out a quick little T-chart here for us of the points that I've graphed already for you so that you can understand a little bit better how this transformation is working. So I have the points 0, 0, I have the point 1, 1, I have the point 4, 2, and I have the point 9, 3. You should recognize this function that I have graphed here as our square root function. It's a good function to analyze because it doesn't have any type of symmetry. It doesn't have y-axis symmetry or origin symmetry, so it allows us to transform it and do some good analysis. So this transformation is going to be our vertical shift, and we can recognize that there's a vertical shift when I have a value that's being added or subtracted to the function itself. It's outside of our function. That means that all of our x values are going to stay the same, but all of our y values are going to be changed by that 5. So instead of a 0, I'm going to add a 5 to that, and it's going to become 5. I'm going to add a 5 to my 1, it's going to become 6. Add a 5 to my 2, it's going to become a 7. Add a 5 to my 3, it's going to become an 8. And that creates my new set of points. So I have the point 0, 5. I have now the point 1, 6. I have the point 4, 7. And I have the point 9, 8. So what you can see on our vertical shift is that it looks like we have physically picked up our graph and moved it up. Now, the horizontal shifts are a little bit different for us. So let's take a look at our horizontal shifts. These can sometimes be difficult for students. So our horizontal shift, we can recognize the horizontal shift because the amount that's being added or subtracted is actually inside the function. So again, I can rewrite this T-chart and we can see how it's going to change for us. We're going to have the same set of points that we had in our other graph. Again, we're working with our square root function. So I have these same points. Now, when we have our horizontal shift, what we want to really be thinking about is what would make this 0. So what I'm really mentally doing for myself is I'm thinking to myself, what value of x is going to make x plus 5 0? And that value is going to be x equals a negative 5. This is what's going to tell me how to move my graph on whether I move left or right. So what I need to do is I need to add a negative 5 to each of my x values. So instead of a 0 for my x value, it's going to become negative 5. And then I'm going to have my 1, and I'm going to subtract my 5 from that. So that's going to move back to 4. And my 4 is now going to become a negative 1. And my 9 is now going to become a 4. So I'm just subtracting 5 from each of these values. Now, when I graph this, instead of the 0, 0, I now have this negative 5, 0. And I now have a negative 4, 1. And I have a negative 1, 2. And I have a 4, 3. So now I can see that my graph looks like it's been picked up and moved backwards. So the horizontal shifts can sometimes be challenging. Now we're going to have our x-axis reflection. So this should tie back to one of our very first lessons of the entire school year and thinking about reflecting our points over the x-axis. So we want to take all of our values here and we want to reflect them across the x-axis, meaning we want to keep the y values. We want to reverse the y values, but we want to keep the x values the same. So we're just going to reflect those down. And this is pretty easy to do just graphically without making a T-chart. So instead of my 1, 1, I'm going to keep that positive. I'm going to keep the x value of 1, and I'm going to flip that down. My next point Here at 2, I'm going to flip it down, and I'm going to flip it down. Of course, the 0, 0 is going to stay the same. So my new points are going to look like this. So now we can see that our new graph looks like it's been reflected across the x-axis. Our y-axis reflection, up here at the top of the page, this should also look like something that we did earlier in the year. We want to take this graph and we want to reflect it across the y-axis. So now we're going to flip our x values. So we're really thinking of these in reverse almost. So our y-axis reflection. So I can flip these across. And I'm now going to have a -1. I'm going to have the point -4, +2. And I'm going to have the point -9, +3. So there's my new graph. And it looks like it's been reflected. The next one that is definitely, I think, the hardest for most students to grasp is the horizontal stretch or compression. So we are going to spend a little bit more time thinking about this one. I want you to go ahead and put a star on this one because this one is definitely one that requires a little bit of thinking. I can recognize a horizontal stretch or compression based on the fact that inside the function, I have something that's being multiplied by my x value, as opposed to on my shift, it was being added. So if you look just side by side here, my shift to picked it up because I was adding and subtracting, my stretch is going to multiply. What we really want to think about when we're looking at this graph to understand what's going to happen is we want to look at this 2x and we want to understand that this is going to move twice as fast. Okay, so the graph and the behavior of this graph is going to move twice as fast, meaning that in the same period of time here, it's going to repeat this cycle twice. So what I'm actually going to do is I'm going to take all of my x values and I'm going to actually divide them by 2. So let's make a t-chart and we can see how this is going to behave. So I'm going to pick some key values here. I've got this point -6, 0. I'm going to pick my key values, my intercepts, and my local maxes and mins. And I have my -4, -2, and my -2, 0, and my 0, 6, and my 3, 6, and I have a 6, 8, and I have my 9, 6. So what I want to happen here is I want to indicate that this is moving twice as fast. So I'm going to take each of these x values and I'm going to multiply them by 1/2. What I'm doing is I'm doing 1 divided by whatever is my coefficient here. So if I take 6 and I multiply it by 1/2, I'm going to get a -3. And my 4 divided by 1/2 is going to give me a -2, a -1, a 0 still. I'm going to write this as a 1.5 for my graphing purposes. 6 divided by 2 is going to give me a 3 and a 4.5. So I can start plotting these points. So the y values are going to stay the same. So instead of this -6, 0, this is going to become -3, 0. And instead of this local minimum that I have, this -4, -2, it's going to become a -2, -2. My next intercept, my -2, 0, is going to become a -1, 0. And I like to start connecting these as I go along. My y value is still going, my y-intercept is still going to stay the same. So I can just go ahead and I can connect that. Continuing on, My next point that I'm looking at is going to be this one right here. That was my 3, 6. That's going to become 1.5. We're just going to kind of eyeball that. 1.5. Notice it keeps that constant spot still constant. My next key point that I'm looking at is this local max. I'm going to move that one. It now becomes a 3, 8. And my last one is going to become 4.5, up at 6, and I get my last little curve here. So if we understand that this graph was supposed to move twice as fast, we can see that it now has. It is moved at twice as fast. So its original domain, the original domain went from a -6 to a +9, and we can now see that that's been cut in half because it moved twice as fast. Our vertical stretch is going to be a little bit easier for us. We don't have to think as hard on this one. So our vertical stretch, we can recognize this because whatever's being multiplied is out in front of the function. It's not inside the function. It's not being subtracted from the function. So on this one, we're just going to take each of our y values and multiply them by 2. So now we're just going to multiply the y values by 2. Nothing special needs to happen when we're working with our y-axis. It's always our x-axis that makes things a little bit more difficult. So these ones will be easy. I'm not going to make a t-chart for this. I'm going to take my point right here, and I'm going to multiply that y-coordinate by 2. So instead of a 1, I'm going to have a 2. And on my next y-coordinate, instead of a 2, I'm going to move it up to a 4. And the last y value that I have plotted here, instead of a 3, I'm going to move that up to a 6. And this might feel a lot like what we did with our shift, but what we want to notice is that on this original point right here, if I have a 0 times a 2, it's still 0. So that one anchors it right where it started. So we can now see that this graph looks like it's been stretched up. So that's a summary of our vertical or all of our transformations of every kind.